Good morning, I'm John Manier from Accu-Slice. This video will be part 9 of the video series on the development of this new automated Accu-Slice system. In the previous videos I described additional features that are added to the system because it's been a continuing process of developing the system, adding new features to it, modifying it, making it operate better and more accurately, and just improving its overall performance, both in hardware and software. So in this video we'll be describing first of all the new electronics console which I developed for the system, and doing a bunch of testing a variety of different boards with different thicknesses from maybe 1 inch up to 10 inches tall, and going from as many as 10 teeth per inch down to probably 3 teeth per inch, just to see what the variation is and how we can improve the system. Okay, here's our metal cabinet with the door on it, and this will mount on the legs on the side of the Accu-Slice table. And all the basic components are installed in here. It's a pretty tight fit, but I get everything to fit. This is actually the top, this will be the bottom. So on the top I have my inputs for the stepper motors, so I have 5 inputs there for the stepper motors. Then here are additional inputs for the electromagnets, the hall switches, and the 2 inputs for the display module. Up top here I have my 3 drivers for the stepper motors. These are the 2 drivers for the indexer, and this larger drivers for the linear actuator. I have 2 power supplies in here. Then here's my Arduino board for all the programming. Then over the side here I have my relay strip, a bunch of terminal blocks over here for connecting the various wires, and 3 voltage dividers to give me my voltage. I need 2 5-volt supplies and 1 12-volt supplies. Then I have a relay for the system, and this relay here will be for the electromagnets. This will be a solid state relay for electromagnets. So most of the wiring is done. I haven't hooked up any of the stepper motors yet because they'll have to be hooked up once installed on the system. But all the wiring now, I have my power going to my voltage regulators, power going to my Arduino, power going to my stepper motors. All my signal cables are hooked up for the stepper motors. So the next thing is to put this on the system and start testing. So this is the new electronics console or module for the automated Accu-Slice system. In the previous video, the electronics console was mounted on a table, and the table was mounted in the front of the system, and it was always in the way. I either had to move it to the left or the right or get it out of the way, and then I had cables running all over the place, even going on the floor. It was kind of just a disaster as far as cabling and just inconvenience to using the system. So I decided to put all electronics in a box which actually mounts to the legs on the system. So it's totally out of the way. So when you're using the system now, you know, it's totally free. It's not in your way of your knees or any way of operating the system. In addition, I shortened all the cables, and the cables all go in directly into the top of the console here, and nothing's hanging down on the floor. Everything's nice and concise and just cleaned up. So it's a much general, cleaner appearance and operation of the system. So the electronics are all inside this console box. Everything's in here. So in here I have 2 power supplies, 1 main power supply for the system, and a separate power supply for electromagnets. Because what I found was happening, electromagnets were causing electrical interference with the rest of the system. So I had to make a separate system, or separate circuit for the electromagnets, just to totally isolate them from the rest of the circuits. So I just have my 2 power supplies. Up here I have my 3 drivers for my stepper motors. This is my Arduino board here. And then I have some terminal blocks on the side here to hook everything up, an exhaust fan to vent the system. So that's pretty much the complete system. It's pretty concise. Everything's contained in the box. In the top I have all my inputs going in. Everything can be disconnected, so it can be moved. It needs to be moved. And just easy to set up and operate. So it's just much cleaner and neater than the previous system. On the front of the system I have an on-off switch. So the power is on and off from the front, and a fuse is built into the front also. So with the addition of the new electronics console, that pretty much completes the design and development of this new automated Accu-Slice system. So my total system consists of first of all, the electronics module. I have my touchpad display here for the operation of the system. I have 2 stepper motors for the linear indexing of the system, and then 1 stepper motor on the end here for the linear travel of the system. I also have my carriage. I have a 30-inch Accu-Slice 2 carriage, and my board's mounted to the carriage. So to turn the system on, just turn on my main power switch, and that powers up the electronics module. And then I can go here and I can do some manual movement as I showed previously in a previous video. Nothing much has changed here since the previous video, but I can jog, back and forth and index the system. Now, I did a little bit of testing before that I'm not showing in the video, just to check out the system. And the first thing I did is I mounted a blade on here. This blade is a 1/2 inch wide blade, 10 teeth per inch, which is a blade I prefer using for boards less than, say, 1.5 inches thick. And I cut a bunch of boards at different speeds just to check out the system. I went from 5 inches per minute up to 35 inches per minute. Now with this 10 teeth per inch blade, actually all of these boards are very good. The 35 inches per minute, which is probably your normal cutting speed, which you're using the system manually, is not too bad. I mean, it has a little bit of a bandsaw blade marks, but that's good enough for a gluing surface. However, the 5 inches per minute, which is the slowest system, almost looks like it ran through the sander. It's really smooth, really nice finish on that. But in general, I think about 10 inches per minute is a good speed for operating the Automated Accu-Slice System with this 10 teeth per inch, 1/2 inch wide blade, and cutting these 1.5 inch boards. So next thing, I put another board on here. This was a piece of, I think this is Spanish cedar. Actually, I ran 12 boards through there, 20,000 inch thick, to see how reproducible it was. And these are all within, 1 or 2,000 of an inch thickness from one another, so that came out pretty nice. And I still have some of that board left on here, so let me run a couple more boards through there to show you how it operates. So I have to go to my auto run mode. I select my forward speed. So my forward speed is going to be 10 inches per minute. My board thickness is going to be 20 thousandths of an inch thick. My reverse speed, I want it to go back much faster, so I set my reverse speed to 75 inches per minute. My blade curve I'm setting to 48 thousandths, and my board length is 29 inches. So let me go ahead and cut 4 boards. Now the one thing I have hooked up, I do have my pause button so I can pause at any time. I did not hook up the emergency stop. I was planning on putting an emergency stop in here, but it would do nothing more than the pause button does. My first thought was to put the emergency stop to turn off the entire power to the system. But that didn't actually work because even though the power was turned off to the system, the power supplies actually had a little bit of memory and it continued running. So it wasn't an emergency stop. It still ran for 2 or 3 seconds after you push the button. But the pause button stops it immediately. So I'm probably going to eliminate the emergency stop and let the pause button act as my emergency stop. So at the beginning of the video here, I'm actually shooting this at actual cutting speed, which is pretty slow. You wouldn't normally cut this slow, but this is cutting at 10 inches per minute. So the first thing it does, it downloads the data from the display panel to the Arduino board in the control module. And it starts all your positions for your board thickness and speeds. And then it next indexes the board to the first board cutting position. In other words, it indexes in to cut my board 20,000 inch thick, and then starts the actual linear cutting of the board. And you can see here it's cutting pretty slow. Now I just increased the video speed to 10 times the actual cutting speed, so it speeds this up for viewing purposes. At the end of the cut, it moves the board back away from the bandsaw blade and then advances the board back to its starting position and then proceeds to cut the next board. And now I just move the camera to the right side of the bandsaw so you can better see what it's cutting. And notice here at the end of the cut it moves the board away from the bandsaw blade. Again, that's just so it clears the blade so it doesn't touch it in the reverse direction. And then it continues slicing the remaining boards until all the boards you've selected have been sliced. And this is all done automatically with no operator input. The only thing I need to do, I usually pull the boards away from the bandsaw blade after they're cut just to make sure they don't bind up with the bandsaw blade. Well, I completed cutting all 4 of those boards unattended, and they all measure between 19 and 21 thousandths, just as the previous one. And the finish on those is, this is a Spanish cedar, which is a pretty much open grain wood, but the surface on that board is quite smooth, quite good actually. Good enough for a glue joint. The only sanding I need to do is to get the fuzzies off the bottom. I want to do a lot of detailed testing on this. And I'm also cutting some boards for some new projects I'm planning on working on. I'm planning 2 new video series coming up. One on making feature rings for bowls and eggs, and another making the bottom rings for bowls and eggs. So there'll be 2 video series I'm planning on working on, using a lot of the strips I'll be cutting to test out this system. So I'll be testing a bunch of boards from boards that are an inch, inch and a half thick up to 10 inches thick, and trying a bunch of different blades and all different varieties of woods. I have some maples, some yellow hearts, some walnut, just a variety of different wood, different hardnesses to check everything out and verify the system. And possibly after doing all that testing, I may do some software modification, so we'll see how that goes. Next, I'll briefly describe the display screen to show you exactly what happens as it's operating. The values on the left part of the screen are your input data, where you input your forward speed, your reverse speed, the board thickness you want to cut, your blade curve, the board length, and the number of slices you want to cut. And then the right part of the screen shows the operation of the system as it's cutting a board. So once all the parameters have been entered, you press the Start Auto Run button, and that starts the operation. So it begins by downloading the data to the Arduino board. It moves the indexer stepper motors in to the position to cut the first board, and then starts slicing the first board. The green and red buttons indicate whether a system has been activated to move, such as the indexer or the magnets. When the bandsaw blade reaches the end of the board being cut, the indexer moves to reverse the board to move it away from the bandsaw blade, so it has plenty of clearance when the board is reversed back to its starting position. The board is moved back to its starting position to get ready to cut the next slice. Once again, the indexer is moved to the position to slice the next slice, and the slicing begins for the next board. The process is continued and repeated until all the boards have been sliced. Notice the 2 information boxes indicate the number of boards that have been cut and the number remaining to be cut. Once again, this part of the video has been sped up 10 times the actual cutting speed, again for viewing purposes to reduce your viewing time. When the last board has been cut, the board moves back to its starting position and re-indexes, getting ready for the next operation. Well, this next board is a piece of maple, and I want to show the complete setup, how we set this up to do by cutting. So first of all, I glued my board to a piece of MDF, which is 1 3/4 inches tall, and I am using my Accu-Sled 2 carriage with the flat plate clamps. So I want to get this set up in the middle. So let me go to manual mode and jog this forward. Going faster. And this board's around 36 inches long. So I'll kind of center it in the carriage. And I'm using different screws this time. These are new screws I just bought. They have one of these Torx heads on them with a washer on, get a little more support. So I just thought these might work better especially for clamping for clamping onto this MDF board. So let me, on my first end here, pre-drill a hole. And I have a Torx bit in my driver. And I usually start by adding the screws to the far left and the right ends of the board, and then follow up with the center screws. And I usually drill a hole just maybe 1/4 of an inch deep, just enough so the screws can get a hold as they start threading in. Then I loosen my coarse adjustment knobs and push my table in until it just touches the bandsaw blade, just like I've done previously for the Accu-Slice systems. So let me move it in so it just touches the bandsaw blade. Take it backwards. I like to move it back maybe an inch away from the bandsaw blade. So I'm going to go to my auto run now. I set my board length to 39 inches. And once again, set my parameters up. I'm going to be cutting at 10 inches per minute. Let's make some boards 20,000 inch thick. I'll make some thicker a little bit later, but for now let's do 20,000 inch thick. My reverse speed is going to be 75 inches per minute. My blade curve is 48 thousandths. My board length 39. And Just going to cut one board initially. This, as always, my first cut is just to square off everything, so everything after that will be perfectly perpendicular or parallel to it. So you see that first board wasn't perfectly straight, but I have a straight flat edge now, so all subsequent boards should be perfectly parallel. This video ended up getting quite long, so I did some editing of some of the cutting just to reduce viewing time. Well, there's the finish on that cut board. It's pretty good. You can hardly see the bandsaw blade marks. So on that maple board, I got 10 boards 40,000 inch thick and 4 boards 20,000 inch thick. And the surfaces are all beautiful on those. This again was a 10 teeth per inch blade, 1/2 inch wide. Next I'm slicing a walnut board using the same 1/2 inch wide by 10 teeth per inch bandsaw blade. And that completes that walnut board. I got 8 boards, 20,000 inch thick. And again, they're very consistent in thickness, you know, plus or minus 1 or 2 thousandths. Very accurate. And very nice, smooth surface. I mean, that's good enough for gluing without any sanding. Next, I'm slicing a Purple Heart board. And again, I'm using the same 1/2 inch blade, 10 teeth per inch. So I got 11 boards out of that piece of Purple Heart. And the surfaces are really nice on this. Again, this was cut with a 10 teeth per inch, 1/2 inch wide blade. You can see the surface on there. It's nice and smooth. Don't need any sanding to glue that up. The next board is a piece of Yellow Heart. And again, I'm slicing boards 20,000 of an inch thick using the same 1/2 inch by 10 teeth per inch bandsaw blade. Out of that Yellow Heart board, I cut 12 strips, each of these 20,000 of an inch thick. And again, the surfaces on those are just great. You can't even hardly see the blade marks. These are the 5 different boards I cut using that 1/2 inch by 10 teeth per inch Timberwolf bandsaw blade. Again, I have Yellow Heart at the bottom, then Maple, then Walnut, Purple Heart, and Spanish Cedar. In total, I cut over 100 boards using that same 1/2 inch by 10 teeth per inch bandsaw blade. And these were all cut at 10 inches per minute. And you can barely see the bandsaw blade marks on these. I just installed a new 1/2 inch wide by 8 teeth per inch blade on my bandsaw. Well, I do prefer 10 teeth per inch for boards under 2 inches tall and less gummy woods. Most of the time on my bandsaw I have an 8 teeth per inch bandsaw blade, mainly because it's a little more versatile. I can do gummier woods such as padauk, and I can do taller boards, maybe up to 6 inches tall. So it's a little more versatile blade for most of the boards I'm cutting. But when I do want a real fine cut, I'll use a 10 teeth per inch blade. But we'll do some testing on this. And I'm starting out with a piece of a cherry. This cherry is about 1 3/4 inches thick. Now I just cut 22 slices of wood from that one board, varying between 20,000 inch thick and 35,000 inch thick. Well, the boards I just cut included some wangi, some padauk, some cherry, some chestnut, and I think this board is Red Heart. And this Red Heart was really hard. Must have a lot of silica in the wood and a little bit gummy, but it did gum up the blade, and actually it started smoking as the blade was getting dull. And whenever the blade starts smoking, the blade is shot. In fact, there's a burn mark here on the board where it was cutting. So I had to stop using that blade, but I did get probably about 70 or 80 boards out of it, so it did pretty good. And the surfaces are all nice. I mean, there's nice, smooth surfaces on these boards. There's no blade marks on them, and they're really good. These are all cut at 10 inches per minute, and the surfaces are all pretty good on these boards. So that completes the testing on this blade. Now what I want to do is pull up my carriage to see how the bearings are. Normally I'm using the Accu-Slice system. I probably clean my bearings after maybe every, definitely after 25, 30 boards. And this thing is run probably about 170, 180 boards, so there's quite a few boards. But the design of the carriage is different. It's more protected, so those roller bearings won't get gummed up as easily. But let me pull off and see what it looks like. And they're really good. I mean, after cutting all those boards, there's very little buildup on those bearings. So between the design of the system and my brushes on the end, did a great job of keeping the sawdust out of the bearings. Also, this cover on my ball screw keeps the sawdust out of the ball screw, so that's staying nice and clean too. So let me just run a damp cloth on these rollers, get it cleaned up. So I just usually clean these with a damp cloth, just wipe off the sawdust. That's all that's required to clean these up. You could use some steel wool if you wanted to, but it's usually not necessary because these are pretty good. So the next blade I'm putting on here is a 6/10 per inch blade, and I'm going with different supports for my board. I'm getting away from these flat plate clamps, and I'll be using these L-bracket supports because I'll be dealing with some taller boards. I've installed my 1/2 inch wide blade, 6/10 per inch blade on my bandsaw. And my first board I'll be cutting will be this piece of yellow heart. It's about 4 inches wide. And I'll run this at some different speeds and feeds so we can see what the surface looks like. And there's my board surface. Again, this was a 6/10 per inch blade, but I was cutting that at 10 inches per minute. Out of that yellow heart board, I cut 9 boards 20,000 an inch thick, and I cut 2 boards 50,000 an inch thick. So now I'm going to start cutting some wider boards. This is a piece of walnut. It's 8 inches tall by about 30 inches long, and I'll be cutting some boards 50,000 an inch thick. I cut 9 boards 50,000 inch thick, and the last piece I cut a board 25 thousandths of an inch thick. Now one thing to notice on these, I did some measurements. When I was using cutting the thinner boards with the 10 teeth per inch blade, I was getting an error between 1 and 2 thousandths of an inch. But in cutting these wider boards with this coarser blade, I'm getting a little more of an error, probably plus or minus 3, maybe even 4 thousandths of an inch. So not quite as accurate, and we definitely see some more bandsaw blade marks. Especially on the end here where the grain changed, I can definitely see more bandsaw blade marks. This next board is a piece of maple, and it's 6 inches tall by 2 inches wide by 43 inches long. And it's pretty much reached the limits of the system. I said it's 43 inches long. I think 45 inches long is probably the longest board you can cut with this rail and carriage. So off this piece of maple board, which was 43 inches long, I cut 5 boards, 50,000 an inch thick. And I did some measurements on it to see what the error was. And I was getting an error between 44 thousandths and 50 thousandths. So that's an error of plus or minus 3 thousandths of an inch, which is still pretty good. I mean, that's quite acceptable. And the finish is actually pretty good on that too. There's some minor bandsaw blade marks, but they're very minor. This would not require sanding for gluing. But of course, if you wanted the finished surface, it would have to be sanded. But for a glue joint, that's fine. That came out pretty good. And what nice thing about running the automated Accu-Slice system, well, this is running. I'm able to do other things. I'm gluing up other boards. Or in this case, I took that first board I cut off, and I ran it through my board sander. In fact, you may see me running that in the background. And I salvaged another board out of that 50,000 inch thick, so I didn't waste any wood at all, even for the piece of scrap that I cut off. So off this 6 per inch blade, I cut this maple board. I cut some yellow heart, and I cut some walnut boards. So what I think I'm going to do is I'm going to go and change the bandsaw blade while this board is still on here. And I'm going to put the wood slicer blade on here from Highland Woodworking. So I'll change the blade, and I'll do a direct comparison on the the same board, the same cut, see how the surface finish varies between the two bandsaw blades on the same board. I just installed the 1/2 inch wood slicer blade. This is a 3 to 4 teeth variable speed blade. And I kept the tension on the blade exactly the same as the previous one. Everything's exactly the same for this operation except that the blade has changed. Yeah, so I'll be slicing the same board I sliced with the previous bandsaw blade, so we'll be able to compare the two. I cut 4 boards 50,000 inch thick with that Highland wood slicer blade, and then 9 boards 75,000 inch thick. And there definitely is more blade marks with that blade, which is kind of expected. The more or less teeth per blade, the coarser the blade, and therefore the more bandsaw blade marks. But I just have this is the Timberwolf 6 per inch blade, and this one on the right is the wood slicer blade, and you can definitely see the difference. But I do like this blade for cutting thicker boards because it is a coarser tooth blade. And in fact, the next board I'm going to cut is got a piece of paduk, which is I think 11 inches tall. And that blade, or that board, would easily gum up my 6 per inch blade. So this blade would be much better for that board. I did do some measurements on these to see how they came out. And I got an error of plus or minus 0.04 of an inch, a little bit worse than the previous blade. And I think that's more a function of the bandsaw blade marks on the board. I'm not measuring, straight across like this. I am measuring at an angle. So I'm measuring across, several bandsaw blade marks. But in getting this, I was getting between, so about plus or minus 0.04 of an inch variation, along the entire length. But still pretty good. As far as the gluing surface, that's a little bit rough. I would probably run that through my board sander to get a little bit smoother finish for sanding, or for gluing. Okay, this next board I'm be cutting with this wood slicer blade is a piece of paduk. And this is a board that I glued up, probably at least 6-8 months ago for some previous testing. And the board is about 11 inches wide by 32 inches long. I said I glued this up like 6-8 months ago to a piece of MDF. And what's happened now is actually warped. It has a significant warp, probably at least a 1/16 of an inch warp. So when I cut off, I'm going to lose quite a bit of wood starting off. But then the subsequent cuts will be fine. But again, that's something to keep in mind. If you're gluing up boards to cut, I wouldn't wait too long to cut them, because the wood will change and it could warp on you. So it's best to cut them right after you glue them up. But let me go ahead and mount this on the bandsaw, and then we'll do some cuts on it. Notice that as I'm slicing additional boards, I'm cleaning up the first scrap board on my board sander so as not to waste any wood. Well, I was able to run that first board. It was a scrap piece, and I got a thin piece out of it by running it through my board sander. And I got 3 additional boards cut out of that piece of paduk. And the surfaces are pretty good. Not a bad surface finish. That again, this was run at 5 inches per minute, a little bit slower speed. Well, I completed the testing on this wood slicer blade. I cut some paduk, some maple, and some of this dark wood. And I did run this at 5 inches per minute to give it a little better finish, but these surfaces came out really nice. This concludes this 9th and final video on this new automated Accu-Slice system. Over the past few months, I've made a lot of changes to the system to definitely improve it. A couple of things we had changed, moving the display panel up top here. Makes it much easier to use the system, easier to use the pause button to stop it, to put your parameters in. It's just more convenient having everything up top. Likewise, putting electronics console down on the legs, another major improvement to get everything off the floor and out of the way and reduce your cables from not hanging all over the place. So just a much cleaner looking system. The system worked quite well. The linear ball screw, which is covered, kept the ball screw nice and clean, so there's no sawdust buildup in that ball screw. Likewise, the change that I made to the carriage design, where the sacrificial fence protects the bearings, and these brushes clean the servers right before the bearings, so the bearings stay a lot cleaner than they do with a normal Accu-Slice system. So overall, the system worked quite well. Changes in the future, probably nothing much major. I'll be making one minor change. I'll be replacing this emergency stop button with a reset button. Because the one thing I found is, I started a process, maybe I was planning on running 10 boards. After running the first board, I found something needed to be changed. And the only way to change it now is to actually turn the power off to the whole system. So I'm going to replace that with a reset button. And what the reset button will do, it'll reset the Arduino computer program. It won't touch the display, so when I reset the Arduino program, it'll reset the program, start from the beginning, but all my data that I put in the screen will still be there. So it'll be a nice change to the system. So up top here I'll have my pause button and a reset button. Putting the two stepper motors, one on each end, kept it nice and parallel, so I had no issues with parallelism changing as I was running the system. Everything stayed nice and straight. Electromagnets that I put in here, I got two heavy electromagnets. They held the table quite nicely and reduced vibration, so it did a good job. Likewise, the additional bracing I added to the system definitely improved the stability. So this system now is very solid, doesn't move at all. It's nice and stable. All that just contributes to giving you more accuracy with the system. As part of this testing of the system, I did a testing of a lot of different boards and blades to verify the system worked, but in doing that I also verified some information which I sort of suspected and just verified it once again. Number one is that the more teeth you have on a blade, the smoother the cut. And the less teeth you have on a blade, the coarser the cut, but the less gumming up of the blade. So you're always compromising smoothness of the cut versus gumming up of the blade. But basically when I'm cutting boards less than 2 inches tall, I'll probably use a 10 teeth per inch blade, unless the wood's gummy. If it's a gummy wood like rosewood or padauk, I'll go to a coarser blade. But boards under 2 inches tall, and like maple and walnut, I definitely use a 10 teeth per inch blade. For boards from like 2 to 6 inches, I'd probably use an 8 teeth per inch blade. And again, if it's a gummy wood, I'd probably go to a 6 teeth per inch blade. Boards over 6 inches, I'd probably use either a 6 teeth per blade or go to this wood slicer blade. Wood slicer blade is good for boards over probably 8 inches tall, and especially good for gummy woods. But I cut some padauk with this, which was 11 inches tall, and there's no gumming up of the blade at all. It worked very nicely. And I'm staying with 1/2 inch wide blades. I prefer that for my slicing of boards. And the main reason for that is because the blade is narrow. If you go to a 3/4 inch wide blade, there's more chance for that back edge of the blade touching the side of the wood and causing some blade drift. But staying with a 1/2 inch wide blade, you actually get a better result. As far as accuracy of the system, I got, when I was using the 10 teeth per inch blades, I was getting accuracy of plus or minus 1 or 2 thousandths of an inch. When I went to the 6 and 8 teeth per inch blades, I was getting accuracy of maybe plus or minus 3 thousandths of an inch. And when I went to the wood slicer blade with the 3 to 4 teeth per inch blade, I was getting accuracy of plus or minus 4 thousandths of an inch. But it seems that as you get a coarser blades and get taller boards, you lose some accuracy of the system. And that just may be a function of the bandsaw blade marks on the board. As far as speeds of cutting, I did quite a bit of testing on all the different blades at different speeds. And again, the slower you cut, the smoother the cut. Because what's happening here as you're running the blade slower, the blade is actually like a planer, and it's staying in position and smoothing out those saw marks so you get smoother cuts. So most of the work I did with the system here, I did with either 10 or even just 5 inches per minute. Most of the boards I'm using 10 inches per minute, but when I got some of the heavier or the thicker boards and using this 3 to 4 tooth blade, I went to 5 inches per minute to give me a little better results. But overall, the system worked quite well. The data came out very good. Everything was very accurate and reproducible. and I'm quite pleased with the system and continue to use it going forward. So once again, thank you for watching this video. If you have any questions or concerns or comments, please give me a call or drop me an email. We're always happy to hear from you.